On your formula sheet, you get the following double angle identities. These become new tools that you can use for anything. And we saw with the proof here that we can use 1 plus 1 equals 2. Brilliant idea from kindergarten. To prove that sine of 2 theta is 2 sine theta cos theta. If we did the same thing with cos of 2 theta, you would get cos squared theta minus sine squared theta. And in your textbook, they show you that if this is true, that cos 2 theta is cos squared minus sine squared, well, I could change the sine squared to 1 minus cos squared, and then I also get that cos 2 theta is 2 cos squared minus 1. And if I started with the cos 2 theta is cos squared theta minus sine squared theta, and I replaced the cos squared theta with 1 minus sine squared theta and rearranged it, I would also get that cos of 2 theta is 1 minus 2 sine squared. And so on your formula page, they give you 3 formulas for cos 2 theta, only 1 formula for sine 2 theta, and 1 formula for tan 2 theta. And these become new tools that we can now do more proofs, more solution questions, more solving questions. So let's look at a couple of examples that involve the double angle identities. Once again, it is helpful to have them mostly memorized, right? If you see a sine squared plus cos squared, your brain has got that one pretty much memorized already. You start to think it equals 1. But now we have a cos squared minus a sine squared. It's not equal to 1, but it's equal to cos 2 theta. So if we have these mostly memorized, it's going to help us because we need to be able to recognize them and solve them in certain questions. Example 1, look at the one off to the side. Given angle theta is in standard position with its terminal arm in quadrant 4 and cos of theta equals 2/5, I'm going to stop reading right there. Doesn't this already sound like questions we've done before? Just reading that up to the comma. Given angle theta is in standard position with its terminal arm in quadrant 4 and cos of theta equals 2/5, I'm not even going to read the rest of the question. This should already trigger in you a strategy you've used a lot of times. What do you do when they tell you cos is 2/5 and it's in quadrant 4? What have we done almost every single time with a question like this? We've drawn a triangle. Where did we draw that triangle? We drew that triangle in quadrant 4 because it told us it's in quadrant 4. We went back to our nearest x-axis so that this would be our reference angle. And if cos is 2/5, we would know adjacent over hypotenuse. We could do a squared plus b squared equals c squared and find the other side if we wanted. Square root of 21. Then if we read after the comma, it says determine the exact value means no decimal places, of each trig ratio. A, it wants us to find sine of 2 theta. Okay? Sine of 2 theta is one of your formulas. This is why you have to have it mostly memorized. So when you see that, your brain goes, ooh, I have a formula for that. The thing that sine of 2 theta is equal to, it's equal to 2 sine theta cos theta. Well, from my triangle, do I know what sine of theta is? Yes. Sine is opposite over hypotenuse. It's in quadrant 4. Sine is negative in quadrant 4. It's going to be negative square root of 21 over 5. Do I know cos of theta? Absolutely. They gave us cos of theta in the question, and we can see it from our triangle. It's 2 over 5. So if I multiply this all out, this is 2 over 1. How do we multiply fractions? Multiply your numerators. Negative 4 root 21, multiply your denominators, over 25. So we have to have our formula memorized enough to say that, ooh, I have a formula for sine 2 theta. Which one is it again? Then your formula sheet comes in handy. For part B, cos 2 theta. Well, for cos 2 theta, we have 3 formulas on our formula sheet. And we can choose any one of the 3. Sometimes there's one that's better than the other. Sometimes they're all equal. In this one, they're mostly all equal. If I had to pick the best one for this case, I would choose this one. The reason I would choose this one is, do you see the other 2 have sine squared in them? This is the only one with just cos squared. Cos of theta, which is 2/5, which helped us build this triangle, was given to us in the question. When you're given something in the question, if I asked you, okay, read the question, what's cos of theta equal to? You'd be like, 2/5, because it says it in the question. Very hard to get wrong something that says it in the question. Okay? Sine of 2 theta, or sine of theta, sorry, from our triangle is negative root 21 over 5. We had to figure that out. Could you have made a mistake figuring out the square root of 21? Possibly. Might you forget the negative sign because it's in quadrant 4? Possibly. Probably a bigger chance of forgetting the negative than making a mistake on the square root of 21. But there's a possibility of making a mistake when figuring out sine of theta. So when I have a choice, if I can choose the one without the sine of theta, then I limit my chances of making a mistake. Now, I can figure out this question. It's equal to 2. Cos of theta was 2/5, so cos squared of theta would be 2/5 squared minus 1. We need to get our answer as a fraction in the end, order of operations, square first, so we're going to get 2 times 4 over 25 minus 1. How do we multiply fractions? Multiply your numerators, multiply your denominators. How do we subtract fractions? We need a common denominator. And we get cos of 2 theta is equal to 17 over 25. Negative, thank you, 17 over 25. Perfect. I'm going to add a part C to this one. It's pretty easy part C in what quadrant? Is 2 theta. Theta's in quadrant 4. They told us that. Don't tell me quadrant 8 for 2 theta. See what I did? Yeah, there's no quadrant 8. But what quadrant would 2 theta be in? And how do we know? So the first thing people try to do is they try to imagine this angle here and like double it and try to picture where that would be, and then they run into problems. That might be happening right now. Sorry? Third quadrant. That is right. What did you do to figure out quadrant 3? Right. Sine of 2 theta is negative. Cos of 2 theta is negative. In your cast rule, where is sine and cos both negative? In quadrant 3. Perfect. Okay. Questions for practice on this one? Number 9.